Would it be possible to attach massive rockets to the Earth and shove it around?
We do attach massive rockets to the Earth, but then we let them go.
We do. Fly free rockets. Rusty Quill presents Enthusiasm. Hello, friends and fans, and welcome to Enthusiasm, the show where we talk about a few of our favourite things. I am your host, Helen Gould, one of the best Rusty Quillers. And today, we're talking about space, and I am delighted to be joined by Bryn, Josh, Marissa, and Paul. As always, we're going to introduce ourselves alphabetically. So, Bryn, can you give me your pronouns and tell me who you are, what you do?
Hi, I'm Bryn, pronouns he, him. I am part of Rusty Quill, I guess. I have been for a long time now, like 6.5 years or something. I appear mostly in Rusty Quill Gaming as Hamid, but you might also know me from the Stellar Firma Science episodes, where I quiz our resident idiots, Ben and Tim, about their knowledge of science. And here I'm going to be on the other side of that equation, so we'll see how that goes. Many years ago, I did study astrophysics, and I hope that my knowledge is not horribly out of date.
We'll find out. Josh, can you give us your pronouns and tell us who you are?
Hello, I am Josh Fox. My pronouns are he, him. I am a tabletop role-playing game designer, the designer of such space games as Last Fleet and Flotsam Adrift Amongst the Stars, and I really like space. I don't have an astrophysics degree, sorry about that.
That is desirable but not essential. I joke, I'm so happy to have you here. It's been a very long time since we last spoke. All right, Marissa, can you give us your pronouns and tell us who you are and what you do?
Yeah, sure. My name's Marissa. My pronouns are she, her. I'm one of the Rusty Quill editors. You'll probably mostly hear me on Rusty Quill Gaming and also on Enthusiasm. I also don't have an astrophysics degree, but I do like space a lot, so here I am.
Wonderful. And last but absolutely not least, Paul, can we get your pronouns and can you tell us who you are?
Yeah, I'm Dr. Paul Sutter, pronouns he, him. I don't have an astrophysics degree per se, but I do have a PhD in physics that I got from the University of Illinois in Urbana-Champaign in 2011. And my astrophysics knowledge goes out of date every single day.
Oh, bad news, Bryn. Wonderful. Okay, let's start with a very easy and simple question then, which is, what do we all think is interesting about space? I'm sure that this is...
Oh yeah, start small.
Yeah, we're going to start small. These are one-word answers only. For me, I like that it's big. Next person.
Well, that's why they call it space, because there's a lot of it.
That is true.
Absolutely.
That is true. It's also very pretty. Or at least I think it is. I remember when we went to Alex's wedding, we were out in the middle of Wales and there was no light pollution at all. And you looked up and you saw the whole Milky Way and it was all purple.
I think it is very pretty, but yeah, as another Londoner, it's so rare that we get to see any of it. It's sad.
Yeah.
Yeah, I live New York City and I grew up in the Midwestern part of the United States out in the middle of the cornfields, and I enjoyed a lot of night skies. And even though I don't live in New York, there's so much light pollution near me from New York, from Hartford, Connecticut, from Boston, Massachusetts. Every single horizon is bathed in glowing light, and we can see some stars up here, but it is not what I'm used to, and I really do miss it.
Aw. Genuinely, what is it that draws people towards space? Like, what do you find interesting about it?
I mean, you said it's big, and I do think that's a big part of it. You know, like it's
yeah,
it's so big that it's, you know, it boggles the mind, and it's crazy impressive, but it also contains therefore so many possibilities. And you know, I know for me it's partly sci-fi stories, but it's also, you know, for as long as I can remember, I was just fascinated by black holes because, you know, they're so bloody weird apart from anything else.
Yeah.
And yeah, like the weirdness, the difference to everyday life, the bigness, and yeah, therefore the possibilities it contains in that sense.
You might think it's a long way down the shops,
Yep.
but that is just peanuts to space.
What is that?
I was going to say the same thing. It's
Hitchhiker's
Guide to the Galaxy.
Oh, have we all read that?
I haven't read it, but I've watched the movie. I'll count that.
I won't count that. I'm sorry.
Actually, I have to confess to not. I'm just about to start reading it with my son. I've listened to the BBC radio play, which is
the definitive version.
That surely counts.
I have both read it and listened to the radio play and seen the movie, and I think they are all valid versions. But I would say the BBC radio play is the best version. So,
I love it. So I was going to definitely say the bigness of space, and I think there's something about the vastness of space that allows you, and the emptiness. I mean, one supposes to sort of project anything onto it, and I think that's one of the things I like. There's so many different stories that you can tell about space, whether it's an empty universe or one that is teeming with other things, or one that seems empty but really isn't. And I think that's what excites me about it.
Cool. What about you, Marissa?
Yeah, I think I'd probably agree with most of everything that was said so far, but I think one of my favorite things about space is how beautiful it is. I'm also from a very cornfield part of the US, and, that's the one thing I miss about living there is being able to see space, because especially like when you see the whole Milky Way galaxy, it's just so beautiful. You could really just stare at it for hours.
Yeah, there's a reason that we have been telling stories around the constellations in the Milky Way and the new stars that occasionally appear. We've been telling these stories and recording these things for millennia, as far back as we can go. Some of our earliest writing is actually just astronomical records. And that tradition has continued all the way into the modern era. And what really draws me to space and studying astronomy and astrophysics is a surprising connection that we have discovered over the past few hundred years between us and the larger cosmos. And that connection is the fact that we can find physical laws, that we can develop theories and hypotheses that are able to describe and encapsulate these forces that are unimaginable, these time and distance scales that are way beyond the human experience, that we can write on a chalkboard an equation that describes the history of the universe over 13.8 billion years, that we can simulate on a computer the death of a star, that we can discover these physical laws that truly are universal, that we can set up an experiment in a laboratory here on Earth and understand how hydrogen behaves on the opposite side of the Milky Way. And it's that connection, that universalism, which really was the birth of modern science with Copernicus and Kepler and Galileo and Newton. They were discovering the universality of physics. And that is what gets me going in the morning.
That's lovely.
The connection between what's in the heavens and what's here on Earth is such a good way to put it. Like, that there was definitely in earlier ages there may have been a disconnect as much as we were looking up and telling stories about the stars. But yeah, I love that idea of the connection between what's there and what's here. And I talk a lot about the abstract sense of space, and astrophysics is a study of the universe as a whole. But there's all the exciting things in the solar system too. Like, if you can get a pretty ordinary telescope and look up and see another planet, and like that's an equally exciting way to enjoy space. And we live in an age where this has only been true for 70 years, where human beings have been to space and human beings have walked on the moon, and I think that's really cool too. Like, human beings have been around for 10,000 years, a bit more. 20,000 maybe, but the fact that for a tiny fraction of that
I think if I remember right, anatomically modern humans arose like around 40,000 years ago to 200,000 years ago, somewhere around there. But yeah, like this very brief amount of time where we have been physically exploring space, not just looking at it.
And hopefully in the near-ish future we'll go a bit further, but I guess that's still to be determined.
So one of the things I think is cool about space is the unknowns as well. I mean, that's sort of relating to what you're saying. Like, what was what was there before there was space? What lies outside space, if anything? What would it be like to be inside a black hole? And this is just things that I, as a foolish non-physicist, can imagine. I can only assume that those of you who actually understand stuff can think of even weirder questions to ask.
I mean, if I remember correctly from one of those Stellar Firma science episodes, if you went inside a black hole, you would spaghettify? Is that an accurate way of describing it?
Yeah. I mean, this is the cool thing about those unknowns. Like, we do not know what happens at the center of a black hole. We simply don't.
Yeah.
We don't know what happens in the earliest moments of the universe. We simply don't. But around a black hole, surrounding a black hole, it is just gravity. It's just Einsteinian gravity. It's general relativity. It's gravity that we've understood for over a century. And using that knowledge of what we do know, we can predict all these crazy things like spaghettification.
Yeah.
I love also that that's the actual term. Like, when I first heard it, I was like, oh, Bryn's making up a funny word. But no, that's actually what you call it.
That's what it's called.
It's real science here, folks.
Hell yeah.
I can actually help you out here because I've been into a black hole a couple of times. And both times there were extra dimensional evil entities in there. So I think sample size of 2, that pretty much says what's in there, and we know now.
The mathematical process of induction.
The really annoying thing about black holes is not only once you cross the event horizon, you can't come out. Once you cross the event horizon, there is a finite time until you are obliterated at the singularity. You can, and the amount of time is given by the mass of the black hole. For a supergiant black hole, millions of times more massive than the sun, it's a handful of seconds. And no matter what you do, no matter how you fire your rockets, no matter what you do, the singularity, the point of infinite density, is always in your future. It's always right in front of you, no matter where you turn around, and you will hit it in a finite amount of time. What happens at the singularity is beyond known science.
Wow. I'm sorry, I'll say it, I'm getting starry-eyed now because there's nothing I like more than hearing someone explain this stuff. I do want to go back to something that we were just touching on earlier, which is science fiction to do with space. And I'd be interested to know if we all enjoy that, or if there are how should I put it? What our standards are in terms of what we regard as good science fiction about space. Marissa, do you have any opinions on science fiction and space?
Yeah, so in terms of science fiction, I think that's actually what got me into space in the first place, not the other way around. I would say that I'm very forgiving in the science fiction that I watch. I really love some of the old Star Trek TV shows that you're like, this is definitely outlandish, but space is also sort of outlandish to the average person. So who knows? Maybe there are space whales and all of these ridiculous entities. I don't know. But I would say in terms of science fiction, there's really nothing that I would say, this is, ridiculous, because like I think Bryn was saying earlier, that space really has these infinite possibilities. So, maybe it's possible somewhere. I don't know.
Josh, you write games about space.
Yeah, totes.
I assume you strive for intense scientific accuracy at all times, Josh.
I strive mostly for the opposite, I would have to say. That's because I don't know enough about space science, as has now been remarked numerous times, to really do a good job of that. But I mean, I think I like any kind of space-based fiction that knows what it wants to be, right? So I like the hard, super duper realistic, it's just 3 people in a pod on the outside of Europa trying to survive for 5 minutes. I like the weird and wacky stuff like Star Trek or Nine Fox Gambit or Star Wars for that matter. I like stuff that has planets teeming with weird aliens, and I like stuff that has no aliens at all. I just think if it knows what it wants to be and it's got something really strong to say, then, and that's the great thing, like I say, you can project anything onto a space-based story, right? Because it could be anything out there.
I absolutely adore sci-fi, and I absolutely I am a pernickety nerd, but I don't really demand scientific accuracy from my sci-fi. Star Trek, is the thing I've been a fan of for as long as I can remember. Absolutely addicted to Deep Space Nine as a teenager. One of the things I love about the sort of Deep Space Nine Voyager era of Star Trek is they did have a full-time scientist on staff whose job was to edit every script, not for scientific accuracy, but for what they would call scientific plausibility. And so actually I think Star Trek is pretty, if you talk about this kind of scale of soft sci-fi down to hard sci-fi, Star Trek is closer to hard sci-fi than you might imagine a lot of the time, because they do at least make an attempt. Or they did during that era. I can't speak if they have the same procedures in place in the modern era. Whereas, Star Wars is pure space fantasy as far as I'm concerned. And I still adore it, and I don't mind. My pernickety nerd side does come out. The thing that really grates with me is inconsistency. Like, if you have a strong premise, if you set your own rules and stick to them, totally on board. Kind of however accurate those rules are to what we might think of as reality. But if you start to break your own rules, or if your rules start to, just get thrown away again, or rules that are seemed to apply once just don't in another situation, then I start to I lose my immersion, and I lose my, what's it called, when you buy into a premise, and
your suspension of disbelief.
Suspension of disbelief, yeah. If that goes, then I find it really hard to keep engaging. So that's the thing for me that's a problem. It's not really realism, but consistency in my sci-fi. Yeah. And, well, even in my fantasy as well, to be honest. But, yeah.
What do you think, Paul? Is it difficult for you sometimes to watch silly space films?
No, it's not difficult. I know it is for other astrophysicists and astronomers and scientists and lawyers and doctors and engineers. But it's not difficult for me because when I watch a movie or a TV show, I'm not interested in grading homework. I do enough of that. I just enjoy it. It's a story. It's obviously not taking place in our universe. It's obviously not playing by our rules of the universe. So why should I judge a movie or a TV show in the universe that they are portraying by the physics that I know about our universe? It's not our universe. It's playing by a different set of rules. So as like what Bryn said, as long as the movie or show stays consistent and it sets up the rules and tells a good story and I get to enjoy it, I could care less whether they're jumping into wormholes or shooting laser. It doesn't matter. That's not the point. If I wanted accurate science, I would open up one of my textbooks because that's what it's designed to do. If I want to have a good time, I watch a movie or a TV show.
Yeah. I have a very similar experience because part of my job is reading people's books and telling them either for sensitivity checks or for editing checks. And so now if I'm doing it for pleasure, I turn all logic and rationality off. Like I can't approach anything with that same amount of rigor because it's tiring and I don't want it to feel like work.
Yeah.
Is everyone familiar with the possibly apocryphal tale that they when people begin their career at NASA, one of the tasks they ask them to do is watch the film Armageddon and list as many mistakes as they possibly can.
Really?
And the record is something like 250 something.
Wow, I've never heard that before.
I have no idea if it's true. It's the kind of thing that could just be a lie made up by the internet, but I think I really hope it's true.
If you can do that, like pull it off, name all 250, do they have to let you be an astronaut?
Who knows? I mean, maybe.
I will give that a try.
If you do that and 50 push-ups, you're an astronaut.
I'm in.
I think it feels too easy. If there are 250 mistakes, they should get a more accurate film and see, raise the difficulty level.
Are you going to have a physics enthusiasm? Because I definitely think you should.
I think this is it, really, more or less.
Yeah. This basically...
It might be happening around us.
You want to talk about space, you got to talk about physics.
Yeah.
That's true.
And I am terrible at physics. It's one of the few subjects I got a D in at one point. I ended up with an A, but only because I was getting extra tuition at home, like 2 hours every day. So while I'm on the subject of thinking about physics at school, I was taught that Pluto was a planet. Can anyone remember why they said it wasn't a planet
Yeah.
afterwards. And then, is it a planet again now?
No.
No.
So, if I remember correctly from my astronomy camp as a young child,
You went to astronomy camp!
yeah, I would be happy to talk about astronomy camp because it's one of the things that got me into space. But I
Oh my
remember
God.
that we talked about Pluto shares more characteristics with an asteroid than with a planet, if I remember correctly. I remember that we talked about that it seemed more like a asteroid that could be found kind of near the area where Pluto is, like the asteroid belt out there, instead of an actual planet. And I think now it's classified as a dwarf planet. Is that right? That's my extremely, I think I was in like 8th grade when I took that class, so...
Can I give my answer? Because I want to say it before someone who actually, one of the physicists is able to correct me.
Go for it, Josh.
It's more fun
I'm all ears.
to let the ignorant people go first. So I think the reason it's a dwarf planet is because it hasn't cleared its immediate vicinity of objects. I think there's something about, like, to be a planet, you have to have cleared your, I'm going to say region of space, that's probably not the right word, of other objects, but like drawing them, presumably they fall into your gravitational well.
So you're saying Pluto is too close to the closest planet to
Something
it?
else, I guess. Yeah. So I mean, obviously, it can't be completely true, can it? Because we've got the moon around us. But I guess it has to either be have crashed into you or be in orbit around you. I think that's what I heard. Now you can hand over to the people who can tell me wrong.
Well, it's my turn next because I will then get corrected in my turn. Basically, I mean, this is classification in science, and as Paul said earlier, we get to make the rules. And so we've made some rules about what makes a planet. It's certain criteria a thing has to meet to be a planet. And the problem is, if you want Pluto to be a planet, then there's like 3 or 4 other objects in the solar system which would also fall under the same definition. Like if your list of criteria is you must be A, B, C, D, well, it turns out there's actually something like 13 objects in the solar system that fit that criteria. And some of them are just obviously not planets. They don't look like planets. They don't look like what we think of when we say this thing is a planet. And so you add in 2 more criteria. You add in criteria E and criteria F. And when you do that, well, it turns out that Pluto is no longer in the list of things that meet all those rules. So basically, that's more or less the situation. But I'm happy to, again, have even more knowledge thrown my way in my turn.
So it's because some cranky scientist didn't want there to be 13 planets. That's what I'm hearing.
I mean, basically, this definition came in 2006.
Yeah.
Okay.
As a part of a vote of the International Astronomical Union. They were meeting in Hawaii that year because we pick very, very good places to have our conferences.
Absolutely. But there's also a couple of really big, good telescopes in Hawaii, aren't there?
Yes, up on Mauna Kea.
Yeah.
But that had nothing to do with the conference. It was just the conference was in Waikiki. And prior to 2006, there had been no strict definition of a planet. Basically, if it orbits the sun, it might be a planet, it might be an asteroid, and we had generally decided that the stuff in the asteroid belt is asteroids and everything else is a planet. And Pluto was included as a planet in that definition. But in the late 1990s and early 2000s, we started to find more and more objects in the outer solar system alongside Pluto. There's Haumea, there's Makemake, there's Eris, there's all these cool objects. And we started to wonder, should we call these planets? And we suspect that there's a lot more objects out there that we simply haven't detected yet, that we might be facing a situation where we have somewhere around 10,000 planets.
Oh, wow.
Because if it's not an asteroid and it's orbiting the sun, it's a planet. So this decision, which was controversial at the time and is still controversial even in the astronomical community, finally defined planet and picked a definition of planet specifically designed to exclude Pluto. Because our choices were 8 planets or like 10,000. And we went with the definition that gave us 8 planets. And the criteria is exactly what Josh mentioned, is that in order to be a planet, you have to orbit the sun. You have to be big enough to be round. and then you have to clear your orbit of any other junk. And Pluto has a massive moon compared to its Charon. It's like half its mass or something. Oh. And there's a bunch of other junk in that general vicinity. If that definition sounds arbitrary, it's because it is. It was arbitrarily chosen so that Pluto would flunk. It's like a teacher designing a test with questions that they know that you are not going to get right so that you get your D in physics. And since then, the arguments have gone back and forth. Pluto is now classified as a kind of planet, a dwarf planet. Just like Ceres in the asteroid belt is no longer an asteroid, it is a dwarf planet. And there's like a dozen other known dwarf planets. In practice, if you actually open up astronomical journals, astronomers refer to Pluto as a planet because it's easy and convenient. So even though by legalistic standards, Pluto is not a planet, a lot of people argue it does look like a planet. It has interesting surface features. It has a source of heat on the inside. It has nitrogen glaciers that are currently sloshing around. It's raining water ice. It's raining nitrogen and snow on Pluto right now. If you look at a picture of Pluto, it looks like a very interesting, active world. And you might be tempted to call it a planet, but I'm not in charge. I think Pluto should be a planet. I think we should have 10,000 planets in our solar system. I think clearing the orbit is not a property of the object itself. It's a product of its environment. The argument is like if you were to take Earth and move it to the orbit of Pluto, we would get demoted to dwarf planet because there's too much stuff out there. And so that has nothing to do with Pluto itself, but there are arguments for this line of thinking being coherent and consistent. And so who cares? Call Pluto a planet if you want. IAU does not have a police arm to it. There are no IAU jails. You can do whatever you want.
That is extremely encouraging.
Yeah, that's really important too. Like scientific language and accuracy is not the same as everyday language, you know?
I think then, on the confirmation that the official stance of this podcast is that there are 10,000 planets.
I'm voting 8. I'm voting 8. I'm on the other side of this debate, I'm afraid.
Too bad. I'm directing this show.
I'm happy to lose. I just want it on the record.
Well, we'll be back in a minute while we hash out this debate. Hello, everyone. It's Helen here. And today, I'm talking to you about a new show on the RQ network called I Am in Askew, a mind-bending, surrealist horror drama that's perfect for anyone who's into creators like Junji Ito and David Lynch. I'm into both of those creators, so it's certainly going on my list. The show follows David Ward, who is trapped just beyond the human world in a murderous city, which also happens to be alive. A mysterious woman helps him to survive, but she has motives of her own, namely, to burn Askew down. Search for I Am in Askew on all podcast platforms, or visit iaminaskew.com to find out more about what's going on in this bizarre world. Happy listening, everyone. And welcome back. So, I have a really hefty topic to talk about next, because, actually, no. I want to check this first, with Bryn, because I think it's Bryn who I heard this from. As I recall, time travel has something to do with gravity? Don't laugh at me.
What's so funny about that?
That doesn't sound like something I'd say.
Okay, that's not you verbatim. But you told Tim and Ben about time travel, and it had something to do with something unexpected. It was like...
I mean, gravity affects the flow of time.
Yes, that was what you were talking about.
So time, I might have been talking about time dilation. I mean, it's true that if time travel were to exist, then probably it would have effects on gravity, or gravity would have effects on it. But I think that may be talking about time dilation.
Okay.
Rather than time travel.
So then how did time travel and space interact? Because surely there are some weird... okay, yeah. I know time travel doesn't exist, just to be clear. But if it did, what would that do to, like, our conception of, like, space-time, I guess?
Time travel does exist.
We're going forward in time.
Yeah, but that is traveling through time. You are moving. All of us are moving in the dimension of time, and that's important to remember.
That's really inspiring, actually, Paul. We are all time travelers together.
Yeah.
And we travel at different rates too. I mean, that's like a cool thing that I know about physics. Yeah. That like if you're close to a black hole, then, or something heavy anyway, then time, I'm going to get this right, slows down so that your time is moving faster for you than everyone else. Let's just say I'm right about that. I'm sure what I said made sense. And also, if you're traveling really fast, same thing, right? So we like in a real sense, time is not this simple kind of one-way thing, right?
Didn't something like that happen with the astronauts on the International Space Station, where it seemed like they were aging slightly less? Is that true?
Oh, tell me more about that, Marissa.
I think so. I'm sure I'm going to botch this and then have to pass it to Paul, but I know that there's been a study on identical twins where one is an astronaut as one is not, and the effects that space has had, but I'm not sure if they actually studied time or aging, or if it was just the effects of how being in space affected your body compared to staying on Earth.
Yeah, that was the point of the twin study. This is the Kelly twins. One stayed on Earth and one went to the space station for like over a year. And then they came back and studied the effects of being in a microgravity environment it has on the human body. But you are right that astronauts in the space station experience time a little bit slower than us here on the surface by something like a microsecond every year.
Oh.
It's an absolutely tiny difference.
Mm-hmm. It's still cool, though.
But measurable. We've taken atomic clocks and put them in airplanes and measured the effects of time dilation.
And it's the basis of GPS as well. You have to take it into account to get accurate GPS readings. The fact that the satellites that are sending the GPS signals measure time differently to the receivers on the ground. If you didn't take that into account, your GPS would not work.
Huh. I think that's what I'm remembering. And my brain translated that into satellites and time traveling. Or something. So now, Bryn, you see, Tim and Ben are not the worst at science.
They laugh at me and mock me while they do it, Helen.
I will never laugh at you.
Has everyone seen The Wandering Earth?
No. Tell us about it, Josh.
Oh, well, first thing, go and f***ing see The Wandering Earth because it's amazingly cool. So it's by Cixin Liu of The Three-Body Problem and other such kind of Chinese physics books. But physics fiction books. So it's every one of his books, as far as I can tell. I've only read 2 of them, so sorry, Cixin, if I got that wrong. They're all about some sort of weird premise in physics and then spinning a story around that. And in this case, it's about, for some reason, we need to move the Earth to a different orbit around a different sun or something. I guess the sun must be dying or something like that. So they fit these giant rocket boosters to the Earth and use it as a spaceship and fly the Earth through space.
Yeah, that basically happens in Mass Effect at one point, but it's an asteroid. And you have to stop the asteroid from crashing into Earth because they wanted to put the asteroid into orbit so they could mine it properly.
Everything has been done in Mass Effect. I mean, obviously, I wasn't to know that.
Hell yeah, everything's been done in Mass. Sorry, I won't make alien sex jokes.
There's a whole physics thing that happens. I think like a moon or something gets too close to the Earth and all of the atmosphere starts getting siphoned off. And I remember looking at that thinking, God, I mean, to be a physicist watching this, you'd be kind of like, either, wow, this is amazing, I can't believe how well they've done this, or really angry. I don't know which.
So the moon steals the atmosphere from the Earth?
I don't remember whether it's the moon or they fly too close to another planet or something. But yeah, there's a whole kind of atmosphere stealing thing going on, and they need to stop that from happening. Otherwise, everyone's going to die. I'm not spoiling too much of the plot here because I can't really remember very much about what happens. I have a crap memory for stories, so don't worry. I've probably got it all wrong.
Huh.
But it's on Netflix, so you can go and watch it. I think it's in Chinese with subtitles or something. So I love that kind of international science fiction stuff that's is getting more and more of that kind of thing. It's really good.
Would it be possible to attach massive rockets to the Earth and shove it around?
We do attach massive rockets to the Earth, but then we let them go.
We do. Fly free rockets.
I mean, to generate enough thrust to affect the momentum of the Earth would require consuming so much of the energy present on the Earth that it's impossible for that reason. In that sense, would be my take on it. Like, the actual energy required would be just astronomical I guess in the literal sense. And so that feels like the major barrier. I mean, you'd also, could you construct something large enough to create the thrust even? I don't know.
But you only did your astrophysics degree like years ago,
indeed.
Bryn, so you're probably wrong, aren't you?
And I mostly studied black holes, so...
Yeah, to give you a sense, the kinetic energy of the Earth is around 2 × 10⁻29 joules. To put that into context, that is the entire all the energy consumed by humans every year for about 1 billion years. Is the kinetic energy of the Earth in orbit around the sun.
That sounds like a lot.
Yeah.
It is. It sounds like a lot because it is a lot.
And if you somehow manage to change the kinetic energy of the Earth, the most likely effect would be you'd either start flying away from the sun or you'd start flying into the sun. Because you'd mess with the orbit, basically.
Oh, yeah, because the Earth is spinning.
Yeah.
Yeah, I forgot that the Earth is spinning.
I think you want to fly away from the sun. That must be the idea.
Guess.
Could you just nudge it a little bit so that it's still got its same kinetic energy but pointed in a slightly different direction?
What you can do, like, let's say you were to sap some of the energy out of the Earth. What would happen is it would move down towards the sun. It would come to a closer orbit. In the act of moving closer, gain speed. And so you'd be in a closer orbit, moving faster with overall less energy. That's it.
What if you had a bag of negative mass?
Negative matter, and you kicked it. Well, if the Earth was made out of negative matter, then if you tried to pull energy from it, it would move further away from the sun.
You got a serious answer to that question,
Yeah.
Josh. So
I'm happy with that. Yeah, I think we've solved the problem.
I want to go a little bit more spacey now instead of... although I love these hypotheticals, I love just asking Paul more and more absurd things. I'm so sorry. I can't get rid of the idea that you thought you were going to come on and debate like intense scientific theories.
No. This is way more fun.
I want to touch on aliens. Again, that's not meant to be an innuendo, but like I want to like talk about whether we think that there is sentient life out there apart from us, because Alex told me a really depressing paradox. He said that either all the aliens before died a long time ago, or they will only exist a long time from now, or we're the only ones that will ever exist. That is a very, very terrible summary, and I was extremely depressed after he told me that. What do we think? Because I feel like space is so big that there must be other sentient life. I feel like just as the sheer probability of it, there must be something else out there that can think. I don't know how the rest of you feel. What do you think, Marissa? You went to astronomy camp. You were looking at planets.
Well, so I have a couple opinions about aliens. Originally, I was like, there's no way that there could be aliens.
Oh.
But then I went to, of course, my astronomy camp, and we started talking about the fact that some bacteria can survive in space. So I was like, okay, well, maybe there can be life out there, but it's not necessarily sentient like us. Like it could be like bacteria or, things like that. And then I started thinking about it more and thought maybe it's possible for aliens to have evolved on other planets. But then I was like, you know what? I don't think I have the mental energy to deal with aliens, so I'm just going to pretend that they don't exist. And that's basically my opinion now. Like maybe they're out there, but I'm going to hope that they're not, because I can't deal with aliens too.
Oh, fair. I think that's fair.
That's a great line of thinking. Aliens probably don't exist because it would make me uncomfortable.
I mean, I think it's rock solid logic, but
well, I think there was Arthur C. Clarke who said either we're alone or we're not, and both possibilities are equally frightening.
Yeah. I think that's going to be my new theory on aliens. I'm just going to adopt that.
I don't think it's very frightening to think that we're not alone.
Really?
I'd find that kind of comforting.
I mean, I think it's a really hard question to answer. There's the very famous Drake equation, which tries to estimate the probability of there being alien life, which is like, okay, what is the number of planets in the universe? What is the probability that on any random planet, life begins to evolve? What is the probability that if life evolves, it becomes multicellular? What is the probability that if multicellular life evolves, it becomes sentient? Because it seems perfectly possible that, you could have, single cellular life like bacteria without those other two things happening. It seems possible you could certainly have multicellular life without sentience. Like, the dinosaurs existed on Earth for a long time. And as far as we're aware, they were, mostly killed off, slashed, changed by the change in circumstances on the planet, rather than that they may or may not have have evolved towards sentience. We have no way of knowing. But it's, we only have one case study, which is our planet. So it's really, really hard to know what these probabilities are. I think I agree with you, Helen, in that, there's several 100 million stars in our galaxy, or is it 1 or 2 billion? I've completely forgotten the latest estimates.
It's a few 100 billion in our galaxy.
Wow.
And there's the same number of galaxies in the universe as there are stars in our. And that if you add all those together, there's so many places in the universe. There's so many stars, and I think a huge fraction of those stars must have planets. Like, we've discovered exoplanets by the buttload in the last few years, and I think no matter how tiny you say the probability of the various forms of life evolving are, the universe is big enough that sentient life almost certainly exists somewhere else in the universe. I also think that the laws of physics as we currently understand it mean that it is not and never will be possible for us to interact with that other life. And I don't know if that is a depressing thought. I'm afraid it might be. And is that any different from saying it doesn't exist? I don't know. But that's my own, feelings on that question. But there are still a lot of unknowns. And fundamentally, it's a hard question to answer, I think.
So I asked it at the end when we're all tired. I don't think that the idea that that there is other sentient life out there, but we'll never meet, that doesn't sadden me so much as to think that we're alone, because to me that means that in the future someone might come by and be like, oh, there were people here, that's kind of cool. I like the idea of someone else discovering like the mark that we've made, I guess. Now I'm thinking about all the theories around how to tell people not to touch radioactive waste, which we would have to inform the aliens about.
Yeah, I think Bryn and Josh and Marissa all basically echo my own thoughts. It's impossible to know. We simply don't know until we actually discover it. Things like the Drake equation are essentially useless because we don't know. We don't know any of these numbers. Yeah. We don't know any of these probabilities. We're just spitballing. And so we might as well just spitball we can just skip over the Drake equation and just say we don't know. We are hunting for life out there in the universe. We're listening for radio signals. We haven't heard anything. We are actively searching for biosignatures on other planets. We're looking for oxygen in alien atmospheres with TESS, with the James Webb Space Telescope. We are actively searching for life. We haven't found any yet. As far as we know, all available evidence indicates that we are totally alone. But like you said, Ellen, there are just so many stars, so many galaxies, and even a tiny probability gets multiplied by that huge number, and you probably, maybe, I hope, end up with more than one intelligent civilization operating in the universe at any one time. But the scales in time and distance between any intelligent species are so great that even though I personally believe we are not alone in the universe, but we are effectively alone.
Yeah.
But only in the same way that it's like a really long way from Scotland to London. So like hardly anybody bothers to make the journey. That's a really bad example. You know what I mean? It's like we're alone in the sense of being a small village that's out in the Arctic Circle or something like that. We're not alone in the sense that we don't exist. I was really interested in what you said about the I think it is the Fermi Paradox, Helen. It's a sort of troubling thought, the idea that if there is intelligent life in the universe, it probably evolved like at a significantly different time from us. Like it's very unlikely that it happened to pop up at the exact same time that we did.
Yeah.
And that means it's probably had a really, really long time to develop to its technology. And that probably means that it should have very, very advanced technology. So the fact that we haven't come across them indicates either that they wiped themselves out before they could get to that point, or that there's for some other reason why they haven't spread across the entire galaxy. You know, they haven't reached the singularity, which is what kind of, you know, we're all hoping we'll get to a point of kind of post-scarcity and being able to spread out amongst the stars and so on. No one else seems to have done that, otherwise we would have bumped into them. I'm not sure I quite buy into that, because exactly for the reasons everybody's been saying, you know, these vast distances in space and indeed other universes, you know, it could be that there's no other life in our galaxy, but that there is in some other galaxy, the vast distances of which would mean that even if they did have hugely advanced technology, they might not be able to reach us in the time available. So, I think that the Fermi Paradox could be an argument against anyone ever reaching faster than light travel, I guess. But I don't think it's an argument against sentient life. And I certainly cling to in rather the opposite logic to Marissa's. I cling to the comforting thought that there are lots of cool life forms out there. But there's no way of knowing, is there?
I kind of like the idea that they're all having the same discussion.
There's an enthusiasm in another galaxy.
Oh.
I think it's interesting, you know, every sci-fi includes faster than light travel, basically, or at least faster than light communication. And, you know, I at least have not encountered a story where there is none. And I think, you know, if humans are ever to expand beyond the borders of our solar system, I think the form that was going to take is likely, you know, a sort of a generation ship style thing, you know, where you strap some engines to an asteroid and you take thousands of years to fly an asteroid from one solar system to another and hope you can find a way to land at the other end, basically. And, you know, and once you've done that, you've put a message or some people in a bottle, put it out to sea, and you'll never know what happened at the other end. And, you know, I don't think that the sci-fi we imagine, where there are kind of networks of connected solar systems, that to me seems probably impossible. But it may be that one day there will be people, you know, who are, for some definition, humans that do live outside our solar system. That I hope that is true. But the laws of physics, you know, do not favour, kind of, as I understand them, don't favour, you know, that interstellar contact. You know, we might be able to have multiple humans living in different places in our solar system, but beyond that, I think that may be more or less as far as our horizons will ever extend in that sense, and that we will just have to hope that some of the people who left made it on to the other side in that sense.
I really like the idea of just plopping everyone on an asteroid, putting an engine in it.
See you later.
Yeah, vroom vroom. I'm sorry, I'm not usually this silly, but I think I have accepted that I don't know anything about this, so I'm like, okay. No thoughts, head empty, space.
Well, isn't that the message of enthusiasm? You can still love something, be fascinated by something, want to know more about something, even without having to know it or, understand it on a, academic level.
Yeah, that is absolutely one of the central premises of the show, for sure. Yeah, I think we're going to have to end it there. Though I could genuinely keep talking about this for a really, really long time because I love the idea of space. But for now, it's goodbye from me. Goodbye. And it's goodbye from everyone else. Do you want to say goodbye, everybody?
Goodbye.
Goodbye.
Enthusiasm is a podcast distributed by Rusty Quill and licensed under a Creative Commons Attribution Non-Commercial Share-alike 4.0 international license. It is directed by Helen Gould, produced by Laurie Ann Davis, with executive producers Alexander J. Newell and April Sumner, and edited by Marissa Ewing, Tessa Vroom, Jeffrey Nils Gardner, and Catherine Ranella. Thanks for listening.